Welcome to the 8th grade Math Homework Helper Series. Tonight's homework is Poly-3, subtracting polynomials. We'll start with some vocabulary. Like terms. Terms that have the exact same variable raised to the exact same exponent. So you can see with the yellow circles that I have here, we have the exact same variable, x, raised to the exact same exponent, to the third power. In the blue boxes, we also have an x, but it's raised to the second power, which makes it a different kind of term than the x to the third power. Simplified is when a polynomial contains no like terms. So in this case, we have two sets of like terms. We have the x thirds and we have the x to the second powers. If we combine them, positive 3x to the third power plus positive 3x to the third power becomes 6x to the third power, and the negative 4x to the second power and the positive 1x to the second power become a negative 3x to the second power. This is simplified because I have only one x to the third power and only one x to the second power. Additive inverse. The additive inverse is adding the opposite. For example, if you have a plus b, it becomes negative a minus b. The signs change on all parts. You could think of it as multiplying the polynomial by negative 1. So if we had a plus b in parentheses and we multiplied it by negative 1, that would distribute negative 1 to each part of this. So negative 1 times a is going to give you negative a. Negative 1 times b is going to give you negative b. When subtracting polynomials, you actually want to turn the problem into an addition problem. I'm going to show you 3 steps to successfully subtract polynomials. So for example, if you were looking at the polynomial 3x third minus x plus 4, and you were subtracting from it negative 4x third minus 6x plus 6. Step 1 is actually optional. You could leave the polynomial in this form up here as a line, but I like to set them up in column order actually. So for step 1, I suggest that you set them up this way. Take the second one and move it underneath the first one. And then once you've done that, you can move on to step 2, which is you have to find the additive inverse of the lower, if you're stacking it, or second, if you're leaving it in a line, polynomial, which means you're basically going to multiply the entire thing by negative 1. So in this original example, I'm going to change the signs of everything in here by multiplying it by negative 1, and that's going to give me positive 4x to the third power plus 6x minus 6. The numbers didn't change, the variables didn't change, the exponents didn't change. The signs are the only things that changed. Now that I've changed the signs, I can look at this as an addition problem. And now I can add these polynomials. So my x to the third powers, 4 plus 3 is 7. My x's, I have a negative and a positive 6, a negative 1 and a positive 6. So that's going to give me positive 5x. And a positive 4 minus 6 is going to give me negative 2. We'll start by taking a look at question 2D. So we have 2m minus 6m squared minus negative 2m squared minus 3m plus 4. So the first thing I want to do is think about how I would change the signs on this. So it would be as if I multiply by negative 1 and then I turn the subtraction into an addition problem. So that's going to look like that. I'm going to have a positive 2m squared, a positive 3m, and a negative 4. Now I need to think about how I want to bring this over. If I brought it over exactly the way it's written right here, my m squareds and my m's wouldn't line up. And I want that to be the case. So I'm going to take this apart. And one of the nice things about polynomials is that you can think of it almost like they are connected like Legos. And so because they're connected that way, they can also be disconnected. So I can take the 6m, which occurs at the second end of the problem here, and put it at the beginning. And I can take the 2m and line it up with the 3m over here. And it really doesn't change a lot. I just need to put a plus sign between them. And now that I have that, I can go ahead and actually do my addition. So negative 6 and plus 2 gives me negative 4m squared. 2 plus 3, 5. And since I'm doing nothing with the negative 4 over here, I can just bring it down. For number 5, you're asked to find an expression for the area not covered by the bird, given the area for each rectangle. So we have the area of the entire rectangle is 12x squared minus 4x, and the area that the picture of the duck takes up is x squared minus 2x minus 1. So I set these up in column order, lining up the x squareds and the x's. I have to keep in mind I need to change and find the additive inverse. So if I multiply by -1, I get negative x squared plus 2x plus 1. And now I can go ahead and add these up. And so I'm going to get 1 from 12 is going to give me 11x squared. I have -4 plus 2 gives me -2x, and my plus 1 just comes down. Lastly, we'll take a look at question number 6b. Find the missing side length based on the perimeter of each figure. So I have 3 sides, and I have the perimeter of the total. So for step number 1, I want to add up those 3 sides. So I line them up so that the like terms are stacked above each other. And then I go ahead and add them. And that gives me 2x squared plus 7x plus 7. For step 2, I'm going to take the original perimeter, 3x squared minus 10, and I'm going to subtract from it this. But keep in mind, I need to change the signs. I need to get the additive inverse of this. So my positive 2 becomes a -2. My positive 7 becomes a -7x. And my positive 7 becomes -7. Now I can go ahead and subtract these by adding them. So I wind up with x squared minus 7x minus 17 is this the length of the missing side. Please use the problems that were done for you tonight to help you to solve any additional problems that are on your homework. And remember, the key to success in math is not only working hard, but working smart.